Hi, my name is Marlee-Ann Lyle, and today I'll be talking to you about my presentation, Miticide and Biopesticide Efficacy against Cyclamen Mite, Phytonemus pallidus in strawberry. I'm co-advised by Dr. Justin Rinkema and Dr. Rebecca Hallett. Cyclamen Mite, Phytonemus pallidus. This mite, formerly known as Tarsinemus pallidus and Steniotarsinemus pallidus, is a mite less than 2 millimeters large. Its origins are unknown, but it was first described in 1891 by Banks at Jamaica, New York. Now it is found globally and is believed to have spread from shipping infested plant materials. This pest is polyphagous, it has a broad host range, and it feeds on young leaves, which reduces petiole development. You can see in this picture here, the adult is oval, orangish white, and the egg is also oval, but it is an opaque white. So why cyclamen mite? Cyclamen mite is a large greenhouse pest. It feeds on African violets, cyclamen, dahlias, ivy, snapdragons, vincas, violas, chrysanthemums, geraniums, fuchsias, begonias, petunias, asters, and strawberry. Cyclamen mite has a cryptic life cycle. It lives in folded new foliage where it feeds. Right now there's no action threshold and controls are applied when damage is seen. But this pest is difficult to control because of its size, life cycle, and available miticides. Right now, there's only one miticide registered in Canada for its control, and that's Agromec SC, but only 2 applications of this miticide are permitted per year, which can be very limiting. Why strawberry? The berry industry in Ontario is massive. There are over 600 berry growers in the province. In 2018, over 3,100 acres of berries were sold, resulting in $40 million of farm gate sales, and $21 million of this $40 million was strawberry sales. When cyclamen mite is left uncontrolled in strawberry, plants become dwarfed and they can't produce fruit, which threatens the livelihoods of strawberry growers. So this is a picture of a strawberry plant that has been damaged by cyclamen mite. As you can see, the leaves are twisted and they're turning brown. And this is a picture of a strawberry plant with its fruit that has been damaged. And as you can see, this fruit is unmarketable and will be a loss. The 2 objectives of my research are: 1, to develop a fast, effective molecular technique to detect cyclamen mite, and 2, to test the efficacy of biopesticides on cyclamen mite. In this presentation, we'll be focusing on the latter. To date, there have been 4 biopesticide spray experiments. There was a summer 2019 field biopesticide spray experiment, a winter 2020 greenhouse biopesticide foliar spray experiment, a summer 2020 greenhouse biopesticide dip experiment, and a summer 2020 greenhouse biopesticide foliar spray experiment. As you can see, there's a trend. For the summer 2019 field biopesticide foliar spray experiment, there were 8 treatments with the surfactant Agril 90 added, a control of water, Agromec SC, Gwen 1708, which is a conventional miticide that's not registered for use in Canada, Grandivo, Venerate XC, and BP Protect, which are all biological biopesticides, Ecotrol Plus and Veg Oil, which are both oil biopesticides. So there were 6 rows of 12 cyclamen mite infested jewel strawberry plants at the Jordan farm near the Vineland Research Station, and there were 9 replicates per treatment. As you can see in this picture, these are examples of the plots. All of these treatments were applied with a CO2-powered backpack sprayer. Then they were reapplied, just the biopesticides were reapplied on July 3rd. but for venerate, there wasn't enough for a second application, so Ecotrol Plus was used on the venerate replicates instead. Then a trifoliate was removed from each plant on July 5th and July 18th, and then examined under a stereo microscope to look for eggs and live and dead motiles, motiles referring to adults and larvae. Then the data was analyzed using ANOVA separated by date. So the results for the live and dead motiles, Gwen 1708 significantly reduced the numbers of adults and larvae compared to the controls on both the 5th and the 18th of July. Biopesticides didn't significantly reduce adults and larvae, but a combination of Venerate and Ecotrol Plus had fewer Cyclamen Mite than the other biopesticides and the controls. For eggs, again, Gwen 1708 significantly reduced the amount of eggs for both the 5th and the 18th of July. Again, the biopesticides didn't significantly reduce eggs compared to the controls, but a combination of Venerate and Ecotrol Plus had fewer Cyclamen Mite than other biopesticides and the controls. For the winter 2020 greenhouse biopesticide foliar spray experiment, there were 4 treatments with the surfactant Agril 90, which were control, Agromec SC, Entrust, and Venerate. Entrust and Venerate are both biological biopesticides. And there were 4 rows of 6 Cyclamen Mite infested jewel strawberry plants at the Vineland Research Station with 6 replicates per treatment. So the methods, 2 foliar sprays were conducted on March 4th and March 11th using an airbrush attached to an air compressor. And then the trifoliates were collected 14 days after each foliar spray. And they were analyzed using a stereo microscope. And then the data was analyzed using ANOVA separated by date. As you can see, the most effective treatment was the conventional miticide Agromec SC. Entrust was the most effective biopesticide, but there wasn't that much of a difference between the Entrust and Venerate treatments. For the summer 2020 greenhouse biopesticide dip experiment, there were 6 treatments with the surfactant Agril 90 added, and these were a control of water, a control of no dip, BP Protect, which is a biological biopesticide, Ecotrol EC, which is an oil biopesticide, Captivia Prime, which is also an oil biopesticide, and Botanigard 22WP, which is a biological biopesticide. And there were 6 blocks of 72 Cyclamen Mite infested Anopheles transplants with 12 reps for each treatment. So I prepared 6 1-liter solutions for each of these treatments, and I dipped the transplants for 30 seconds each. Then these were planted, and 1 month after they were dipped, the trifoliates were analyzed using a stereo microscope, and then the data was analyzed using ANOVA separated by date. The most effective treatment turned out to be Ecotrol EC, while the least effective was the Captivia Prime. For the summer 2020 greenhouse biopesticide foliar spray experiment, there'll be 6 treatments with no surfactant. There's a control of water, Agromec SC plus the surfactant, JMS stylet oil, veg oil, Ecotrol EC, and Captivia Prime, which are all oil biopesticides. And there are 6 blocks of 54 Cyclamen Mite infested jewel strawberry plants with 9 replicates each. We're doing this experiment like we did the winter foliar spray experiment by using a paint pen with an air compressor. And there will be 2 sprays, and the second spray will happen 7 days later after the first. And this experiment is still in progress, so I have no results to show you yet. So conclusions. Fenzaquin, Magister SC in the USA, may be a suitable alternative for Agromec SC. The effective biopesticide products that I found were Ecotrol EC, BP Protect, and Botanigard 22WP. Further testing of biopesticide products is warranted. Biopesticides may be best used in rotation with a conventional miticide or other control options to suppress Cyclamen Mite populations. The significance of this research is that incorporating biopesticides into a spray program will both provide organic strawberry growers cyclamen mite management tools and will also reduce their reliance on conventional miticides. Thank you for listening to my presentation today. These are my references. Bye-bye!